Hey guys, welcome back to my channel. Let's solve today's problem 1171. Remove zero sum consecutive nodes from the linked list. Okay, so let me just delete this. Why am not delete? Okay, yeah, let's solve this. Suppose what this question is saying, I have um, a few nodes and just think of this numbers as a node. Okay, now we have to remove all the consecutive nodes that sum leads to 0. Okay, now think of this. If I take this sequence, it will give me a zero sum. 1 plus 2 minus 3 equals to 0. So I have to remove this and make the linked list like this. Okay, this is the intuition, this is the concept, this is what the question is saying. Okay, so how can we think of like this? The most basic approach I can think of is just like an array. I will start from I and try to go till I find the sum 0. Okay. Now suppose I am at I, then I keep on finding the sum till here. But keep on finding the sum 1 plus 1 2. No, this is not equal to 0. 2 plus 2 4. This is not equal to 0. 2 minus 3 is equals to 1. 4 minus 3 equals to 1. Plus 2, 3. This is not lead me to any 0, so I am going to eliminate this. And what I do is move the pointer to here. Okay. Now again checking. 1 plus 2, 3. 3 minus 3, 0. I got a J. So I am going to eliminate this and make the linked list like this. This is the most brute force that I can think of. Okay. And this will eventually lead me to 1, 2. Okay, this would be my linked list. Then I will go from 2 and keep on checking. Can I have a 0? If I not, I'll just simply return the head of this and it will be my answer. Okay, now how can we optimally solve this? Okay, I'll show you the code of this approach also in the ending if you want to see. But let's just go for the optimal solution. Suppose I have 1, 1, 2, minus 3, and 2. Okay, this is my node. So, if you have heard of prefix sum, then it would be really helpful. Okay, now what I will do is I will have prefix sum. Okay, and what is the last node that I had on this node? Okay, suppose I got a sum 2 at which node? 1 node. Okay, I got a 0 sum in the like this position. So like this. So what can I do is just let me just take the view the approach. Okay, so the key would be my prefix sum, and the value would be the last this thing. See, last node where I got the sum. Okay, so what I do is I put a dummy node with sum equals to 0 in the starting. Okay, now I will start from this position. Okay, now 0 equals to let's suppose this as A. Okay, B. What is the sum? 0 plus 1, 1. I got a 1 sum at B. Okay, now C. I got a sum 2 at node C. Okay, now D. 4 at D. Now 4 minus 3 equals to 1. So I have a prefix sum till here as 1. Okay, so I am going to replace this B and put E here. Understood? The last node I'm saying again. Last node. Okay. Then I'll go for 2. It's 3. 3 sum equals to F. Here A, B, C, D, E, N are the addresses of this node. Okay. Understood? This is my hash map. Okay. Let me just use a different color. This is my hash map. And I'm using a prefix and the last node. Okay. Understood? Let's tell me just go for the code. Okay. So I need a prefix hash map. Okay. And I need a dummy node, which would be in the starting 0 and its next would be here. Okay. It would be like 0 connected to head. Okay. Understood. 0 is connected to head. And this is my prefix some hash map where the key would be the prefix sum and the node address is a node. Okay, understood. So this is what it means. This dummy is what it indicates. Okay, so let's iterate on why dummy. Now I need a prefix sum first in the starting it would be 0. Now prefix sum plus plus dummy dot var. Okay, I have added the current node value. Okay, what I will do is if I'm suppose this is my dummy node and this is my one node. Okay, in the starting the prefix is 0. Okay, when I come to this node 0 plus 0 is sum 0. Okay, so it would be 0. And what I will do is prefix comma prefix sum equals to dummy. Okay, I have put 0 as A. This is A. Okay. Now I have to move the pointer also. Okay. This will calculate me the prefix sum. Okay. Let me just return print for you for better understanding. Okay. See. Okay. I didn't print the prefix. See, in the 0, I have a list node of value -3. See, 0, it would lead me to a -3. Okay, because I have a different example. Just think of a different example in the starting. I have like this. So, and this, the key would be the prefix sum and it would be my node. In this prefix sum and the node. Okay. Now, what I will do is, I will simply just move the pointers according to this. What I will do is, again, I'm going to put dummy equals to like this. Again, dummy equals to this dot head and prefix sum equals to 0. And while dummy, I will what I do is put dummy dot next. First, I have to find the prefix. Okay, dummy dot next equals to prefix comma prefix sum. Okay, means what I did was I'm going to mark the first node connected to the next prefix value. Okay, now I will again move the pointer and return the head. Simple. But I cannot use head in this. I have to use res and res dot next. What's the shortcut of this? L. The remove prefix in 0. Some if I'm using this 0, then I have to find okay dot next. Let's run this. Yeah, it's been accepted. The test cases are running fine. Let's try to submit this. Yeah, it's been accepted. Okay, quite efficient. Okay, now what I did was, let me just clear this out. Okay, I'm just finding in the hash map what is this, which node has the sum 0. Okay, which node has the sum 0. And the moment I have the 0, I'm going to put its next value as my current next. Okay, this is the main concept in which I use a prefix sum, prefix hash map for the prefix sum and the last node. Okay, the last node in which I am connecting the dummy with the head. Then I'm going for the dummy and finding the prefix sum and putting the prefix sum and the node here in the hash map. Then I'm moving the pointer. Okay, now same thing. I use this as my to return the, because in the head it will never be the same. So the prefix sum, then again I find the sum, then I'm going to find the next. Okay, this is my approach. Hope you understand this. And if you want to find, if you want to know about the iteration approach where I use I and J, okay, it's just to give you some concept. Okay, so this is the approach in which I use a dummy node and I'm linking the head. This is the same thing. This code is same. In which I'm finding the sum from the ith node and going till j and d. If the sum is 0, then I'm going to put the dummy next equation node next and moving forward. So this is the split high complexity, but the space is really less in this. Okay, as compared to this. It will take space. This will not take the space. The time complexity is highest compared to this. Okay, here are the two approaches. And if you understand this, give a good like and a subscribe. Okay, see you in the next video.